Good afternoon, friends. I hope you get nice tea. We have a very good session this morning and good learning from mostly manufacturing vendors. An architect and nothing to tell. I will show you something about the perception about high-end buildings and security about high-end buildings. This is Mumbai. Mumbai was the first city in Asia to have a tall structure that was Marriott Tower in 1878. This was an industrial structure, it was stone and brick building. It was in the 19th century that we had the first 1,000-foot above tower, 5-foot tower, all about that, with an icon. We have all over trend of high-rise buildings. Speak about that. The current tallest building, of course, you all know is about Burj Khalifa. It's about 829 meters high. And the future building getting ready now is the Kingdom Tower, about 1,000 meters high. The noted architect, celebrity architect, American architect, Frederick White, in 1956 had conceived the concept of about future building by 1 mile, 1509 meters high. We reached already 1,000 meters high, about which are for the construction now. Hopefully someday new people will be able to see it a mile long building also in my lifetime, in your lifetime. Going to the story of the advent of high-rise building, a race started in America, USA in 1901, 20th century beginning. The first building came in the Philadelphia Tower and followed by Metropolitan Towers and older, and all this building came in the first decade of the 20th century. The race continued, the Manhattan Tower came in 23 meters high and Chrysler building. We were building a building over there and past the building, of course, we know about that. After we passed the building came in 1931, the gap of many years before any new step the building came in. So this building definitely one of the remarkable buildings happened. A given name to icons for New York. New York identified by United States building, rather America was identified by this building. The building was built in a very quick span time over there. First time they used aluminium for glazing, and the building had about 1 million square foot of cladding for stone, granite, and aluminium, way back in 1931, about 80 years back. This iconic building is one of the most visited buildings. Right now, 120 million people visit this building. Almost every day, 8 to 10,000 people visit this building and pay about $50 charge to go up to the 18th floor, and this gives a revenue about $150 million per year. For 600 crore rupees, the state ticket for the building going up, 365 days a year, including Sunday, never closes. And yet we don't know who the architect, who the engineer. As a celebrity building, landmark building, iconic building, we do not know who the architect, builder, and engineer was there. In 1930 rather, after Chrysler being built, there was jealousy between kind of investors and real estate people. They wanted to outbuild that Chrysler building, and they decided to build a building and form a corporation called Empire State Corporation, where Mr. Ruskell was made a president from, he was ex from General Motors, and team was made of architects, engineers, contractors, and they asked to make a building as far as possible and tallest building in the world. Do you have any idea how long it will take this building? 102-story building today. When you build it, how long will it take you? Design, build, fit, commission. You don't have any idea? Any guess? Okay, today I'm talking about. How will you do that? So this building was commissioned by architects. The architects and the engineer put together, gave the design concept, GFC for the foundation in 2 weeks' time. Just 2 weeks' time. Very important building to do it.
And the building was constructed in 1 year and 45 days. June 26 started over there, and November 30th building was up. With all the claddings, all the finishing, all the Art Deco interiors done, building commissioned by the President from White House through a remote control. Now that was a kind of engineering skill of the enterprise that time. What kind of technology must have used it to make the building so fast in what 12, 13, 14, 13 and a half months time? I don't think it requires any technology. The only technology I understand which works really well, decision making. There's nothing beyond that. Look at the workforce, the construction. These workforce don't have even gloves, don't have helmets, they don't have safety belts. We call it sky boys. The stairs are in the sky, the rest over there, work over there, they work over kind of just by the clock. The will, the desire of the manpower. They were construction workers, immigrants brought from Ontario, not from New York. This is the 102nd floor on around the 11th month's time, when they're putting up on top of Christ of building. There is a sphere, top sphere of the building was being done there. And they used rivets those days, not even welding. See the kind of enterprise, what kind of construction technique, cranes, thing like lifting equipment they must be having. It's a simple will of the manpower. This building has been now refurbished, constructed for about $50 million in 1931. A refurbishing was taken around $550 million for this building. The building also was struck in 1945 by a plane, by a military plane, by accident. The plane crashed, the Boeing plane crashed. Engine went through the building, fell on the roof of the civilian side, nothing happened. The building was designed to take 10 more floors, but they couldn't have permission. And the building was so strong, but the only thing is, it was having steel of 19 kg per square foot. Construction steel requires, structural steel. The building, as I told you, we have been refurbished recently in 1911. It spent about $550 million for refurbishing, and it has spent about $100 million more to build the building for retrofitting it to make it green. It's the largest building in the world, 2.5 million square feet area, got gold green rating. Largest functioning building in the world has a gold green rating of IGBC, also Green Building Council for US Green Building Council. The architects and engineers gave a concept that time, they call it core and frame structure, which will be followed till now most buildings in the world. They follow this system. And it works. In came in 1906, there was a gap. After that, there were 30 years of a gap because of a recession. The Great Recession came in 1929 after 31. Then we had a new structural engineer, Dr. Fazlul Khan. He was Bangladeshi American resident. He passed through the architecture, architect and engineer. He joined S1 in 1956, and during the 60s he built most outstanding buildings, 100 to 180 story, 180 story buildings, and he gave us the concept of the structural form with the tubes and frames and whatnot, what you call, which most engineers followed till today, and he was known as the Einstein of the structural engineers, the greatest structural engineer of the 20th century. There were a few buildings done by him. We give example of a 44-meter Hancock Center, Wills Tower, one magnificent mile, and he also devised and gave to us, all the engineers, various systems which work and tried tested by him. We call them, to ring frame, we call them tube, diagonal frame over there, and you call everything you know very well, and the kind of bracings and things like that, and those are the buildings which you have got building and framing system put together, have been actually built by him till the 60s. Our tube system here, the bundle tube system over there, which is being followed till now in modern time. But Khalifa, a world tower now in Mumbai, behind the same concept of bundle tube system over there for the safety and earthquake resistance and also kind of your wind forces to strain over there. And this system works very well. All the buildings all over the world have been on this process. Do you know that Burj Khalifa Tower is swayed by 4 feet by wind force? Building may be 4 feet. You won't even notice it possibly. Your 4 feet quite large kind of dimension. It is the architect's design which makes the building safer for earthquake and wind forces. Architect must know engineering, and engineer must know architecture. A combination of architect and engineers who come out with the concepts and make a building more economical, stronger, durable, and resistant to earthquake forces and wind forces there. Engineers do use the wind turbine to check the make the model over there, check the forces for the shear moment for the buildings, and architects learned to give some solution for that. And when a building done by SWM in China, they're given 4 floors, 2 level cutouts of the building. So the wind can flow out. Doesn't cause the pressure in the building. At the same time, they use the space for putting turbines, wind turbine, to produce power for the building, wind power for the building. That's the ingenuity of the architect engineer put together, how to make best out of the circumstances. Here's a building done by at World Pearl Tower in China. A high-rise building, again I told you the form of the building was square, diagonal, straight, sheer, depends on the architect over there. We found that normally say the big square mass building looks more stable, but it's not. A diagonal building forms looks more stable. It's more stable, they're lighter, there's a more kind of mass over here and can take wind pressure and the 3 forces together to make building more stable. And on the principle of that, you put some basins, stiffeners in between. On the same principle, I'm doing a 95-story building in Mumbai, a new corporate, but using composite steel structure. Steel and concrete. Steel has limitations, because a lot of advantages, but limitation doesn't give me the beautiful architecture, the thin slab required over there, don't give me ornamentations. So I'm able to combine both of them together as a skill of an engineer architect that we will do it up to 95 100-story building. Beyond that, I have to think differently. These are buildings form coming up now. Some more building coming same shape to the concrete and steel building. We have many more challenges of building high-rise buildings. The challenges come to the form of building services, engineering services, fire safety, fire planning, executive over there, and security, intelligent building system and whatnot in today's modern life for there. I won't go much to detail about these things because some different engineer people will be tackling that. I did it just to say the building doesn't come only to all building, there are many more things to also put into that. And also today I have a security system which becomes more like an analog system, which becomes more like a smart grid. At the hand of your phone to manage the entire building system, just kind of that technology what we have it. The biggest challenge we have is building facade, building elevation we call that. We have many different kind of materials. Old time, like this building facade is like putting the face to a building, like putting a cosmetic treatment to the building, what you call that. The fashion designers, they do different kind of dressing for their models. Some of them are very traditional, some are very contemporary, some very bold, some are very funky and kind of mod. And so they architects do it. They make the building very ornamental, some kind of make it very contemporary, some make bold design, some make it kind of little funky building. They do kind of a lot of tricks and engineers have to cooperate with them. We have been doing glazing for many years over there. They're very traditional manner, kind of have outer shell with steel structure and steel windows. Our outer glazing was supposed to be always having some steel structures putting on that, which is not very great looking, look like grid over there, like a mesh. And we have engineers be using kind of structure systems to beautify the building elevation also there. But in the course of time, the old way of doing glazing over here. That outer shell was made as supporting members and glass in that over there. Now they were too boring for that. In time to come, the construction industry discovered new material called green material, fixing material called silicones and spiders. Silicone and spiders changed the entire cultural elevation treatment of building facade. And we started using glass as a material, self-supporting material in tension and compression both a shear glass, cutting away the steel and aluminum out of that. There are a few facades happened in the last few decades. What you can see, how much can we play around with the system over there. And entire building facade has been modified in various forms, including that now World Trade Center getting ready now. A few buildings have this facade which have been executed. It shows how things have changed in the last 2 decades. Architects always want to be innovative, and they get engineers to work with them. The team architect and engineers work together to get some different form rather than going to box forms. There are a few examples of towers in Bahar Tower in Abu Dhabi. There's Jeddah Beacon Tower coming over there. The structural form has played a great role. The architect and engineer put together have given form to this. This is the absolute tower which have won the awards the world over for the best building in the world in 2012. A few more buildings in the same shape and time future to see the former building coming up outside India and few in India as well. We like to do a building illumination also. Building should be visible at night time, and LED has given us a great advantage how to do building illumination. And we started using building facade as also marketing material for media. So we pick up the lighting, which is not very heavy, not very kind of a low thing. It's light in weight and light in also power consumption, and give various kind of forms and kind of opportunities how to illuminate your building, how to convert your building into media for ad and marketing purpose. For different companies we're using for their own manufacturing headquarters over there, and we can get different coloring also, like RGB coloring for the same building. One building guy has put in dark, the bank has put in dark, color scheme will put in the building over there. These are kind of opportunities available to us in time to come. Building is to give identity. Like this was the first good building, like Opera House, Sydney Opera House. We say we call it Sydney. It's Australia. Look at we call it Paris. Look at the building called it Paris. Look at it we call it London. Look at it we call it New York. Look at it we call it Malaysia. Look at it we call it Singapore. Look at it we call it Bahrain. Look at it we call it Dubai. What next? India? Waiting. Waiting for you guys to get something good, landmark building, give identity, and hope in time to come, we shall be able to provide some